y double dash plus 4y dash plus 9y equals 0. And we got these initial conditions here. So write down the auxiliary equation then. Lambda squared plus 4 lambda plus 9 equals 0. Solve this then using the formula minus b, which is 4, plus or minus the square root of b squared, which is 4 squared, 16, minus 4 times a, which is 1, times c, which is 9, all over 2a, which is 2 lots of 1. So what do we get here then? Got a minus 4, plus or minus, all over 2. 16 take 36, 4 nines are 36. 16 take 36 is minus 20. So we got minus root, so that's a I. The root 20 is root 5 times root 4, and root 4 is 2. So I'm going to write my root 20 as 2 root 5. I hope that's okay. And then we can simply write minus 2 plus or minus root 5 times I, if you can read that, all over, oh that's it, sorry, because I cancelled by 2 and wrote them down as separate parts. I'm going to write that again, sorry, just tidy that up, that doesn't look too good. So that's equal to then, split the fraction up, minus 4 over 2 is minus 2, plus or minus, and then it's 2 root 5 over 2, which is just root 5i. And I want to compare that with alpha plus minus beta I. This is case 3. Gives, so let's write down the answer now then, for case 3. So y is equal to a sine beta x, and beta is root 5, so it's a sine root 5x plus b cosine root 5x brackets e to the alpha, which is minus 2 lots of x. There we go. Now we've got our initial conditions. Let's look at the first one. Y0 equals 3. So let's turn our attention to this solution. Y0 equals 3 gives, so 3, put that in for y. Sine x is 0, so sine 0 is 0. And then cos 0 will be b, 1 times b, which is b. E to the 0, which is 1. So that tells us then that b equals 3. Okay, good. Now differentiate then. Differentiating gives, so y dashed is equal to, this is a product, this part here is u, this part is b. Don't forget the b is itself a function of function, and these constituent parts in u are also functions of a function. So the sine of something goes to cos of something multiplied by the something differentiated. So the root 5 will pop out. So y dash then equals u, which is a sine root 5x, plus b cosine root 5x, that's u, times the v dx. E to the something goes to e to the something, multiplied by the something differentiated, so the minus 2 can come down to ground level here. So that's u to v dx plus v, which is e to the minus 2x, times by du dx. Sine goes to cos, but the root 5 comes out, the something differentiated is root 5, times a sine root 5x, and then the cosine differentiates to minus sine, and the root 5 comes out again. So put that there, b, and that'll be sine root 5x, close brackets. So there we are, there's our product. Our initial condition was y dashed 0 equals 2. So let's put that in here then for y dashed and see what we get. So y dashed 0 equals 2 gives, so y dashed is 2 when x is 0. This will be 0, sine 0 is 0, cos 0 is 1, so that's just b. Minus 2 times e to the 0 is just times minus 2. Then you've got plus e to the naught is 1, and times this bracket. That should be a cosine there. Sorry, I've managed to write a sine. No, it is a sine. It's the first one that's a cosine. So that's a sine. That's a cosine, which I would have probably said in words. Cosine root 5x. There we are. So what have we got then? E to the naught is 1. Cos naught is 1 times root 5. And then this sine naught is naught, so that will disappear. Okay, so what have we got then? And that was what have we got on this second bracket? Cos naught is 1, so that's root 5 times an a. There we go. So what have we got? B is 3 from before. There. So bear that in mind when we look at this. So that implies root 5a times a is equal to, move that minus 2b over to be with the 2 that's already there to become plus 2b. B is 3 like we said, so that's equal to 2 plus 6, which equals 8. So that implies a equals 8 over root 5, which is 8 root 5 over 5. So then our final answer then, y equals a, which is 8 root 5 over 5, sine root 5x, wasn't it? Plus b, which is 3, cosine root 5x, times e to the alpha, which was minus 2x. There we go. That's the particular solution.